is the image of trapezoid ABCD after a rotation of 110 degrees counterclockwise about point P. Now, this is a rigid motion question from the Geometry Regents of 2023. Now, June, by the way. So, in number 2, there's an image and there's a pre-image. The pre-image, hence the suffix or the prefix pre, is the one that is drawn originally. The prime indicates, the prime marks indicate that that's the resulting shape after whatever has happened. Which transformation is it? A rotation. What makes this true, what makes this a rigid motion is the fact that a rotation does not change the shape or the size of said trapezoid. And any transformation, that maintains the size and shape of an image is a rigid motion. This only is important because you see these types of questions. And when you understand what a rigid motion is, you understand a little deeper what this means. And this question is set up in the sense where you may get confused with the congruency being a part of a rigid motion. Of course, yes, rigid motions are congruent. Their shapes are congruent, but their images are congruent, right? However, that's not the question. If you look further, it says which statement is always true. Well, angle A and angle D prime are congruent, it says. Well, if I look at angle A and I look at angle D prime, in order to say that angle A and angle D prime are congruent, I would have to use some fact. And the only things I know about this is that they're both trapezoids. And in fact, the only thing I do know about it is that also the rigid motion. If I think about that, and also I know that A and A prime in rigid motions correlate because the size and the shape did not change. It may have moved, but that doesn't change the size and the shape. And if A is congruent to A prime, I could go further and say that D is congruent to D prime. And usually we mark these things like this because we don't have different colors on our Regents. So it shows that they're different, but it shows that these two are the same. So anyway, so to make a long story short, so A could not possibly be congruent to D prime. And they don't care about that. They only care about which statement is always true. The only statement that's true is that A prime, B prime, this side here, and D prime, C prime, this side here, are parallel. There is one other question I want to show. Question number 13. It's important to understand the counterexample of a rigid motion. What makes a counterexample of a rigid motion is showing two images that do not hold the rigid motion definition. The rigid motion definition was that after a transformation, any transformation that maintains the image's size and shape. Now, this is the transformation, dilation here. On the set of axes below, triangle DEF is the image of triangle ABC after a dilation of scale factor 1/3. So the dilation of transformation did not maintain the size. It did maintain the shape, but you can't have one part of a definition and not the other and say it's true. All of the definition has to be true for it to be a rigid motion or for it to hold its rigid motion characteristics. So since this does not do that, that's why it's a counterexample. Now, to find the center of dilation, that is a mathematical statement here. So let's go ahead. To find the center of dilation graphically, you can take a straight line and line it up with its corresponding dilated vertices. So A and F, A and D, and then you draw a line from A to D, and that extends out. Now I'm going to do that for each other vertex of this triangle that corresponds. So C and F, and then B to E. Excuse me. And so I'm going to take my, now that, it's not necessarily drawn to scale, but it is pretty close. And since it is pretty close, I'm going to look at my choices here and see which one of these coordinate pairs matches the point where all three of these lines intersect. And that would be 1, 2, across, 1, 2, 3, down, right here. 2, -3. Choice 2. Goodbye.